Hi there, I'm Deep Dylan. Welcome to your AI Injection, the podcast where we discuss state-of-the-art techniques in artificial intelligence with a focus on how these capabilities are used to transform organizations, making them more efficient, impactful, and successful. Hi there, I'm Deep Dylan, your host, and today on our show, we'll be talking to Carolina Torres, Executive Director of Energy Industry Transformation at Cognite. We're going to touch on all things industrial data ops, including the great energy transition underway and sustainability as a data problem. Carolina, get us started. Tell us a little bit about how you wound up in the energy industry and at Cognite, and what is this transformation that you're talking about, or that I'm reading about?
Sure. I started out life as a geologist, actually. Okay. So I entered into the oil and gas industry as a geologist. I spent like 10 years working for ARCO, and then the rest, another 20 years working for BP. I only really worked as a geoscientist for the first 10 or 15 years. And then after that, I went into more of a strategy role, organizational change, and technology. I got very, very interested in how we can use technology to make better decisions.
It sounds like you had a really interesting list of locations around the planet that you've been. Did I read that right?
Yeah, I mean, I don't know if it's that way anymore in the oil and gas industry, but when I joined in the early 90s, there was a lot of moving around and going to a lot of interesting places in the world to work. So I got to see quite a lot of different geographies and different cultures. And I love that about my career. Yeah, I think you were, if I recall right, like South America, like pretty much all over the planet, it looked like. So America, Asia, spent quite a bit of time in Myanmar, which was super interesting, and then in the UK for quite a bit as well.
Awesome. So what is this transformation that's going on, this energy transformation? Are we talking about the transformation to clean energy? Is that basically what we're talking about, or am I?
You know what? I actually think that there's multiple things that are kind of coming together to a head, and some of them are technology, and some of them are actually social, and there's interwoven. So let me unpack that, because it's a complex
please
thing.
do.
So we have digitalization. People want to do a lot of automation and digitizing of their existing historical processes. Okay. We have the energy transition, which is really driven by, climate change. And, there's actually a big push from both consumers and the financial sector to kind of do things in a really different way and to operate our planet in a more sustainable way. And then there's a whole bunch of, what are called fourth industrial revolution technologies like AI, automation, machine learning, computer vision. There's a whole bunch of stuff that's like coming to fruition that can be used to enable those transitions, both the digital transformation and the energy transition. So I think all of those things are coming into play, and the social aspect of it, which I find super interesting as well, is that it's going to require a different way of working. It's going to require a significantly more collaboration than competition. So in the past, business and industry has all been about competing with other folks to win the business, to make the most widgets, to sell the most widgets. And when you start thinking about trying to operate more sustainably, you get to, like, for example, making a change from a supply chain, which is basically a waste stream from one side to the other, from, pulling something out of the ground, using it, making stuff out of it, selling it to people and having them throw it away, to something which could be more like a circular economy, or a circular, not a supply chain, but a supply cycle. And that's going to require a different level of collaboration, a different level of transparency and sharing of information, and having like a common source of truth that, we haven't really been able to do before, but we have the technology to do it. And that technology is available in the public sector, like what Google does, for example.
Can you maybe give us an example of what you mean by, like, what would be an example of a circular supply chain?
So there's a manufacturing company in Norway called Arbacher who has basically, about in sustainability, you have scope 1, 2, and 3 emissions, right? Have you heard about that?
Nope.
Scope 1 and 2.
Tell us all about it. Yeah, I don't know anything.
So scope 1 is, emissions that your business generates.
Okay.
Scope 2 could be sort of side things that are not related to your business. Like say you are a manufacturer who makes drill bits. So in the manufacturing of drill bits, you are creating emissions. That's scope 1. Scope 2, it could be like the supply chain, the material that comes into your shop.
Like the gas that was used to transport the metal or something.
Exactly, the transportation, the electricity, and all that kind of stuff. And then scope 3 is the emissions that your customer emits during the usage of that. Okay.
Of your product.
Of your product, yeah. So if you're an oil and gas company, you have a huge scope 3 footprint because you are selling petroleum to consumers who are then
coming out the tailpipe and into the atmosphere.
Consuming it, and but how in the world are we going to keep track of all of that when my scope 1 is somebody else's scope 3, et cetera? It's like there's no way to actually track that unless we actually share information in a different way than we've done, and the data transparency has to be much better. So this customer of Cognite's called Arbacher created an algorithm to calculate, basically to automatically produce their CO2 reporting at the plant level, at the machine level, or even at the product level. So they could, take into account their suppliers' emissions, add their own emissions for the machine tooling and what they did with that product, that bit they made. And then they can actually hand it over to the oil company that buys that bit with a certificate that says, this is the footprint of this piece of equipment, this product right now at the moment that we're handing it over to you. And then after that, it becomes yours and you can do whatever.
And that's so that the purchaser of the drill bit, if you will, can take that whole chain of information about the product. I guess in that case, that would be scope 2. Take that whole chain of stuff and then incorporate it into their own reporting that goes on to the next step. Is that right?
Yeah. But what ended up happening, which was really interesting, is that then they started renegotiating, okay, what happens if instead of me, I'm the oil company now, instead of me buying that bit from the manufacturer, what happens if I lease it? Oh, and then when I'm done with it and it's all worn out, I give it back to the manufacturer and they can melt it back down and reuse the metal. Mm-hmm. And then that's not really, how does the scope 1, 2, and 3 work in that scenario? But there's actually an incentive in that situation to actually reuse something as opposed to just dispose of it and kind of get rid of that linear waste stream type supply chain scenario and start creating something a little bit more circular, which then reduces everybody's footprint and gets people closer to the net zero goals.
I see. So it's like you've got maybe the emissions from the production of the drill bit, but you also have the emissions from the production of the new drill bit that didn't necessarily have to get built.
Right.
If you don't reuse it, but if you do reuse it, then all of a sudden, you just saved that. And so for the sake of our listeners, why are we doing this? What's new and why is everyone accounting for all of these emissions? And what's driving it down to the business level? Is it executive choice? Are investors demanding it? Is it coming down from UN mandates that ripple in? What's happening?
All of the above, and it's all very interlinked. So yes, there are new regulations in place. Those new regulations are there because of consumer sentiment and the science that supports the fact that climate change and global warming is happening, and it's because of the emissions and the waste and everything else that we as humans are creating. And so there's a big drive, and I think the financial sector has moved into it. The SEC just recently, I think it was 3 weeks ago, announced some new reporting requirements around emissions reporting and sustainability reporting, where customers or companies that have made net zero claims have to now, in their reporting, in their SEC filing, show progress that they're making towards that. And it can't just be like wave my arm and paint everything green. It has to be like, these are the steps that I'm actually taking. I am now recycling my bits. I am now, tracking the emissions of my products, and handing them that information over to my customers so they can do their reporting, et cetera. So I think, there's just a lot of impetus in the world for that.
Yeah, I mean, it clearly, a huge chunk of us realize that we need to, keep the global temperature rise below 1.5 degrees. And there's a lot of motivation to sort of force change here. What are some of the differences in the energy industry? And maybe walk us through a little bit more of like, what's the role AI is starting to play there?
So I think that the oil and gas, the hydrocarbon energy industry has been quite behind in their digital transformation. I think, the financial sector, banks, marketing, tech has moved quite a lot faster into that space, and being able to manage and operate their data, even huge big data, AWS, Amazon, and things like that have been able to manage their data in a way that they have been able to use machine learning and AI to enhance their business, to operate more efficiently, to, even to manage their sustainability information in their data.
Mm-hmm.
Real time, they can track like who's buying what, when, how much, et cetera, and gain some insights by using machine learning and AI to do that. The oil and gas industry also has significant amounts of data, big data, but it has really, really struggled to do that digital transformation and to actually take that data and be able to use machine learning and AI to gain further insights and make better decisions and optimize their business and automate their business. They've struggled with that. And a lot of that has to do with the nature of the data. It's extremely siloed. So if you go to an offshore installation anywhere, there are hundreds, if not thousands, of moving parts. And many of those come from different vendors, the different machines, the pump system and the whatever, they all come from different vendors. Each of those vendors keeps and manages the data associated with their particular machines in their system, in their data model. And so if you want to try to aggregate and amalgamate all of that and get some sort of a view of the entire facility, or even components of that facility, so that you can get some real-time monitoring and be able to make some real-time optimization decisions, either towards production enhancement or towards emissions reduction or whatever it is, companies really struggle. So both in the digital transformation and in the energy sustainability, the energy industry has really struggled, and it's because it's a data problem.
Yeah, I mean, that makes a lot of sense. Like we see that in the manufacturing sector too, right? I sort of break it into two buckets. One bucket is like gathering the data. So this would be like the whole quote big data movement where we're trying to get everything into data warehouses. So you've got, companies are sort of at various points on the spectrum. Some companies, like pretty much every single thing generated is like being warehoused. And then you can have machine learning AI teams going in and trying to figure out how to predict what from this.
Yeah, but I mean, warehousing isn't enough because you have to just putting it in one place. And that's the mistake that a lot of companies have made. It's like, oh, well, we have a data lake. Oh, we've got Azure and we've got all our data in this data lake, and they still can't, there's no relationship mapping, there's no semantic layer, there's no ontology, there's no way to actually connect the different pieces of data in a relational way that then allows people to pull the data and the relationships around that data into a model that they can then do AI. And
I agree 100%. I completely agree with you. But I just want to like go kind of tighten the bow here, if you will, on your characterization of the energy industry, not quite yet having their data sort of even in that mode. So like I guess I'm wondering, or maybe it's a question for you. Is this not maybe a result of the lack of internet-ready sensors on some level? Like because if you think about like a software company, it's fairly straightforward to get all of your data into a warehouse because everything you generate is written by usually oftentimes like a good chunk of it by folks in-house who create the data and just need to put it via API somewhere else. But if you talk about something like an oil company, they've got machinery parts that maybe had sensors on them where they're all Wi-Fi enabled, and there's Wi-Fi sitting maybe out there, and then boom, it's like immediately onto the internet. Therefore, you can centralize it easily. Therefore, you can get it whether it's a warehouse or something with more structured representations. But do you think that's part of what's
It definitely is, and we have a name for it actually at Cognite. We call that the OT-IT divide. So operational tech versus informational tech. Is there. There's a big gap, and the operational tech. I mean, a lot of folks think that they have to upgrade all of their facilities, and many of these oil and gas facilities are 20, 30 years old. But there's a lot of aftermarket sensors that can be added, and they're not very expensive. So we've got a lot of customers that have been systematically doing that. But there's also, you can use AI for doing sort of combined physics and AI models that can help with that. So for example, one of the products that we help enable is something called a virtual flow meter. So if you think about an oil and gas well, oil or gas well, you can put a meter on the well, retrofit one, and that's what can be quite expensive on multiple wells. Or you can create a virtual flow meter using the data that you do get from that well, like the pressure and the volume of flow and several other things. And you can write a hybrid AI model that will enable you to create a virtual flow meter. So that's one of the things.
And what is your goal with that meter?
Well, it allows you to track the amount of flow of production out of that well, which then on the sustainability side, if we're going to that, you can also track the emissions by using some calculations to go from production, barrels produced to emissions. But you can also optimize. You can create some neural net or other optimization
to do some forecasting or something.
Yeah, or basically each well will have a meter that tells you how much it's producing. It's going through multiple systems. It's going through a pressure handling system and maybe a water handling system where it's separating the oil and the water out. And then it's going through multiple systems on the facility, and you can optimize those to maximize production. Turn down this well, turn up that one, this one's really gassy. Let's, you can basically continuously optimize that system as a whole. And you might have 10 wells that are linked up to that one system. And so you want to continuously optimize. And that's all machine learning and AI systems that can do that. Once you've got them each metered and you have the equipment and understand what the equipment throughput is, then you can optimize that system.
You're listening to Your AI Injection, brought to you by Xionyx.com. That's XYONIX.com. Check out our website for more content, or if you need help injecting AI into your organization. How are they done, maybe pre-AI, and where are we with respect to the transformation from that pre-world to the current?
So pre-AI, you had operators, human operators that got to, that were there all the time and got to kind of know the wells, like personally, like the humans do. It's like, oh, that one sounds funny, and that one's doing this, and that one is slugging. And they get to the point where they understand and they know the system really well, and they're optimizing it manually as a human would. They're like trying to take these 10 wells and try to figure out what's, and it's by trial and error, it's empirical, it's, a human process, right?
So I don't know enough about an oil well to know what the flow rate changes look like, but
wells can behave differently. Some of them slug because of the dynamic geometry within the wellbore itself. So they might be sluggish. They might like burp up, bloop, 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 like that. Others are just flowing like steady state, like a nice train. It's, they're going to behave differently depending on, is one of them close to the oil water contact, in which case it's bringing up oil, but it's also bringing up water, which needs to be filtered out. or it might be have more gas in it than the others, that kind of thing. So there's a lot of variables in the system that need to be managed. And some of these operators that have been out there for 20 years operating the wells, they get to know, in this very instinctual way, and they can be really good operators, but they can't really beat a machine that can handle, 50 different variables, or an algorithm that can handle 50 different variables in like real time, kind of be creating suggestions on how you can operate that facility.
Well, give us a sense of the knobs and dials they're twiddling. Like, are they what are they? Maybe just a few of them.
They're called chokes. Every well has a choke, and there's choke settings, and you can think about it like a clock maybe, and there's like 12 settings, and one's wide open and the other one is like different degrees of shut. So you can, but when you choke it back, you're also creating some back pressure, which sometimes helps it produce better. I mean, we're getting into like super detailed, like how wells work. I don't know if you wanted to go there, but it is interesting.
No, I just kind of go with whatever I'm trying, because I'm trying to understand, like create a picture in my head of what's going on. And I don't know whenever else I'm going to get a chance to talk to somebody who knows all about oil wells. So walk us through a little bit, like on the machine side. So you're trying to automate this with the system. Are you learning from the humans, or are you basically able to kind of model the physics of this problem, or is it a kind of a combination maybe where like you said, like the humans are twiddling some knobs, checking out flow, and based on that, they can kind of adaptively hone in on optimal settings? Like, how do those systems tend to work, the automation?
A couple of things. So the company that I work for, Cognite, is primarily a data operations system. So what we have is a machine learning and AI software that brings in data from multiple different sources. So each of the individual wells, plus the water handling system, plus the pumps, the gas compressor system, all the different systems, both the wells underground plus the stuff that's on top, the facilities. And we take sensor data in, we take production data from all the wells, we take temperature, pressure, all the different data from all the different systems, bring it into the platform, create, linkages through entity matching, and really, creating basically like a knowledge graph of the entire system, like a digital twin, if you will. Okay. And then from there, on top of that, either we or sometimes our customers have citizen data scientists and other folks that do this themselves. So our data platform is an open API system. We create those linkages, we create APIs, and then either we can write programs on top of that, or they can write programs on top of that.
Gotcha.
So basically, we develop that platform or that system, and then you can write smart stuff to do insights or automation on top of it. When we do it, we have quite a lot of domain experts that work for our company that understand, facilities engineering, wells engineering, how these things work, production engineering. And so, in addition to our data scientists, we have domain experts that help write these algorithms, and they understand both the physics and the AI parts of how all these pieces work together and how optimization can happen.
So going back to maybe the sustainability part, what do you do on a day-to-day basis, maybe at Cognite, that has something to do with sustainability? Like, what does that mean?
So I think up till now, sustainability and sort of this net zero goals that companies have been, pledging, I guess, to be, net zero by 2030 or 2040. It's relatively new. It's in the last couple of years that all that's come about. Prior to that, there were requirements around environmental reporting. So companies had to generate, for the SEC or for the European Commission or whoever their reporting body was, some sort of a report to stockholders, if they were a publicly traded company, about their environmental performance. In other words, did you have any spills? How much did you emit? A lot of different kinds of things like that. More recently, with the advent of pressure from the financial sector around ESG kind of reporting, and investors are now really looking at different companies and their performance in a much, much deeper way. And they're looking at, environmental and social and governance and how that happens in the company and making investment decisions around that. It's getting to the point, like for newer startups, it's very hard to get funding if you don't have, very, very clearly stated net zero goals and a path to get there. And you're demonstrating that you are reducing your environmental impact, for example.
Are we talking about energy companies? Like, are energy companies trying to get to net zero too? How does an oil company get to net zero?
Well,
are they building carbon capture systems or something?
Some of them, there's all different strategies that companies have. So some of them are building, are really, like, mostly American companies are putting all of their eggs into that carbon capture and sequestration basket. They're, I think that they're a bit behind the ball compared to European and all the other companies, countries, basically, including Canada, are looking at also alternative energy. So if you look at Shell or BP or Equinor or some of the Canadian companies, they are trying to reduce the footprint of their traditional hydrocarbon-based business. At the same time, they're transitioning,
grow their renewables.
They're transitioning to either hydrogen or wind or solar. They're buying EV charging systems. They're creating new businesses that have to do with partnering with cities, for example, to create holistic circular energy solutions. We'll supply you the energy and also the carbon sequestration of all the energy for your city.
Yeah, so that makes sense.
There's a lot of different strategies that companies are deploying to do this. But I would say the traditional American companies tend to be like, oh, we're just going to keep producing the same thing we are, but then we're going to stick it in the ground after.
Like, what's your take on that? Does the energy usage pencil on the CCS systems? Like, I mean, now you need a clean source of energy to power the CCS system that's going to extract the carbon from the atmosphere to put it back in the ground. And you probably don't want to use oil for that.
No, I think they do. I mean, I think they're betting on that oil is going to be around forever. They're still going to need tons of oil. And then they'll just come up with, they're just going to pump it back into the ground.
But so then presumably they're gambling on a significant increase in energy efficiency on the CCS front.
They're banking on gaining some efficiencies on the production side, and then basically, whatever they produce, whatever footprint they have from there, they will net it to zero by putting it all in the ground or by supplying the capability to others. So it's not just, we're just going to put our own waste into the ground, but we'll also, supply that for manufacturers, for example. We will, do the injection and the monitoring of that carbon for customers as a business, which will then, that's a negative number on their balance sheet. Yeah.
I mean, it sounds reasonable if you pull a barrel of oil out of the ground and you sell it to somebody who puts it into the air. If you can pull a barrel of oil back out of the air and shove it back into the ground and do that at a cost that keeps it profitable for you, sure. But I guess I wonder if that pencils.
Yeah, I mean, it's not going to be profitable unless the government creates that regulatory environment to make it profitable. In other words, if the government makes it so that every ton of carbon equivalent that you inject is worth X dollars, like that market, it doesn't exist and it needs to be created, and it's going to have to come from some sort of a taxation scheme or something like that, or a price scheme where every ton of carbon that anybody produces is going to cost them X dollars unless they get rid of it somehow.
Okay.
So it's complicated. It's not just the technology is not there, but also the regulatory environment and the tax environment isn't there. There's a lot of social things that need to line up in order for that to work. And it's very difficult when you have American companies that produce hydrocarbon out of fields in Angola. So how does that work? There's some sort of an agreement that needs to happen between the US and Angola about what the price of that oil is and the hydrocarbon the CO2 equivalent value of that and what it is. So it's very complicated.
I mean, all that.
I personally don't really like, to be honest, I'll just give you my personal opinion. I don't like the whole hydrocarbon, the CC sequestration concept at all. I mean, I think carbon capture is great. There's, some technology that's very, very incipient, very new, where they're taking carbon out of the air and making, product out of it, like basically bricks and things like that. Or you can, use it to pave roads and things like that. It's not energy efficient right now, but it seems like it would be a lot easier to regulate a value for that, where you actually use it for something, as opposed to just disposing of it. To me, the whole sequestration part of that equation is just more of the same linear waste stream thinking. It's not transformative enough.
Perhaps you're not sure whether AI can really transform your business. Maybe you don't know what it means to inject AI into your business. Maybe you need some help actually building models. Check us out at xionyx.com. That's XYONIX.com. Maybe we can help.
Yeah, I don't know. I mean, like right now, there seems to be a market for high quality carbon capture and proof of injection into the ground. Like Microsoft's paying big bucks for this. And there's a bunch of companies that are willing to like run contests, put a lot of money on the table. The challenge seems to be nobody's doing it well yet, but there's a lot of startups being funded at pretty significant rates. So going back to the AI question, like how do folks in the this industrial energy sector, how do they think about artificial intelligence? Do they think about it as just like another tool? How do they think about it?
I think, let me step back a bit. There's every range of client that we have that is on the digital maturity scale. So there's some that are quite immature, and they're just trying to figure out like how they can improve their bottom line, how they can optimize their production, but also like answer their stockholders' requirements for reducing emissions. And they're just like barely just trying to figure that out. All the way to the other extreme, we have some clients that have very, very robust citizen developer programs where they're retraining all of their domain experts, their drilling engineers, their petroleum engineers, their geologists, their financial people. They're training them all in data science and data science thinking. And they're basically saying, we're going to change our entire business. We're going to digitally transform our business so that we're going to have some sort of enhanced decision making across our entire value chain for how we do business. And we're going to take, all the historical knowledge and information that we've got buried in our data files, and we're going to bring info out of that and make it possible for people to query it and analyze it and, perform like analytics on it and gain insight.
And on the other side of the fence, where you see these companies that are sort of struggling to just even capture the data, like what's the difference between these two companies? Is it size? Is it like management commitment?
No, it's not. I mean, it varies. Medium-sized companies seem to actually be the most advanced, I would say, in the sense that they're the most agile. And I'm talking about medium-sized companies like Hess, for example. That's what I would consider a medium-sized company. A big company would be like Exxon or BP or Shell. But the medium-sized companies seem to be able to be a bit more agile and make these kinds of decisions and train up their people and, establish the things so they make decisions quite a lot quicker. The big guys are wanting to do it all themselves. So those guys are talking to Microsoft, and Microsoft is telling them, yeah, you have all this stuff in Azure and it's in your data lake, and you can just use Microsoft product to, basically make a digital twin or get your data, contextualized, create that relationship knowledge graph around your data that then enables you to do AI and machine learning at scale. And so those guys are quite slow because they're big. They have a lot of different assets all over the world. Those assets are very different, the one from the other, in terms of how they're organized and plumbed. and they actually don't have the people or the know-how to do it themselves, but they're wanting to do it themselves. So in some ways, they're quite behind.
That's such an interesting take, right? It's like you have money and resources, you have large pools of employees, so you're committed to like bringing this stuff in-house, even if it takes longer. But because of that, and your non-willingness to kind of go wherever the expertise already is, you end up being slower. What I would have guessed would be a little bit different. Like what I would have guessed is that they would go on shopping sprees for startups and just pull the talent in that way.
No. I mean, some of them are going for big shopping. They're paying huge premiums on really smart people that they're poaching from Google or Uber or, you know, other industries that know it. But then these folks get into the industrial world and they get completely bogged down because they just don't understand the OT. I think one of the things that you probably need to bear in mind in the oil and gas business too is that they are used to, more than any, they're very secretive. Their DNA and their history and their culture is, you know, around exploration and keeping everything very, very close to their chest. They don't, you know, the tech business and even now sort of the marketing and retail is all about being open. And they're like, oh yeah, we're writing open source stuff and everything's open and everybody can see our stuff and here, copy me, you know, it's fine. They have this like totally different culture, whereas the oil and gas and probably manufacturing is a bit the same, and definitely power and utilities is like that. It's like all, you know, competitive advantage is me keeping everything right here, you know, and very,
well,
very
DoD
secret. Nobody can see
sector
it.
is like that too, right?
Yeah. And the oil and gas company is, you know, so that's why this whole DIY thing, they're not going out and, you know, buying tech, and they're not, you know, leveraging those kinds of things at all. They're all just trying to figure it out themselves and be, you know, they think that that's going to give them a competitive advantage.
And then what about like a new energy company like like Tesla? I mean, do they come at it from a completely different angle? They don't necessarily care about sort of legacy energy sources, and they're sort of tech from the core up. Like, what is your take on, you know, maybe not just Tesla, but like some of the newer players?
I mean, most of them are playing more in the renewables space, right? It's going to be wind and solar. It's going to be EV charging. It's going to be battery technology, and things like that. And I do think that that's going to keep growing, and it's already growing at a rate that nobody foresaw. You know, if you look at this, you know, the shape of the graph on, you know, solar and wind, it's massive. And even this year, they bumped up the number of, you know, wind bid rounds for wind leases by, I don't know, they doubled or tripled them this year.
And I don't know, you'll know the stats way better than me, but I keep hearing things like the costs of building a new wind or solar plant are significantly lower than the cost of building a new coal plant or a new.
Yeah. And quite a lot quicker too. If you think about the oil and gas sector, from discovery till you actually have a facility, and what used to be called first oil, like first drop goes into the pipeline, on average is 10 to 15 years and costs billions of dollars, whereas a wind farm, you know, maybe 3 to 5 years, and you know, then you're making money. So I think the hydrocarbon-based energy sector is going to have to compete at a totally different level. And I think that's driving the behavior around, you know, digitization and sustainability as well. You know, they need to be able to make decisions a lot quicker and get at their information a lot quicker to be able to make those decisions quicker and better.
Why would they not just bet on some of the new technologies? Like, why not say, okay, yes, you know, Exxon, I've done oil and gas forever. I also have a very large bank account. Like, why don't I go shopping for new solar companies, new wind companies, new energy storage companies? Like, are you seeing that?
I'm not seeing that in Exxon or Chevron or American companies, but all of the European majors are there already and have been doing it already for a while. So if you look at BP or Shell or Equinor, they're all investing. They've all bought startups in wind and solar. They've all bought EV charging companies, and you know, and battery. They're investing in tech, all of that.
It just feels obvious to me, like, because I don't know why you would tie yourself to a type of energy if you're an energy company. It feels to me like diversity is a natural thing, but do you know why they're not?
So I think there's a couple of different things. So Europe is in a world of hurt because they're very dependent on Russia, and they have not wanted to be dependent on Russia. So the government, the European Union, has incentivized companies to do alternatives. And there's a lot of good tax incentives for doing that, and have been around for quite a long time. So, the North Sea and most of the European oil is dwindling quite a lot, and has been for the past, 20 years. So they've had a lot of drive to invest in alternatives. In the US, it's really different. It's the opposite of that. We have tons and tons of product. It's all over the place. There's a very, very friendly regulatory environment for hydrocarbon production. And, the government really hasn't stepped up to try to, incentivize in different ways. I think, Biden administration is trying to do that, and I don't know if they're going to pull it off. So
I see. I kind of want to stitch the story together because and maybe you can fill in the gaps for me. So this has been a fascinating conversation by far for me. I feel like I'm entering a world that I really know very, very little about. So I feel like this is maybe the first of many conversations that I need to have. But you're painting a picture for me of a world where clearly the climate is being affected. We've got European entities moving towards, wind and solar as energy companies, less so here in the States. But we're also talking about artificial intelligence and the role of it in increasing data-driven efficiencies. Bring it all together for us. Like, what's the best case scenario if we go out 10 years with respect to artificial intelligence and energy?
So I think that the U.S. is going to catch up regulations-wise eventually. We're going to start to put in some regulations in place that will incentivize different behaviors. It's already happening. The consumers are clamoring for it. The financial sector is clamoring for it, and that pressure is going to continue to rise and lead to different regulations. And I think that also the energy industry is becoming more mature. I mean, even 2 years ago, I think there was a lot more digital immaturity and lack of understanding. People were still thinking that sustainability was about reporting what happened last year, as opposed to optimizing what's happening right now, and maybe even making some forecasting and future decisions based on the environmental impact of those decisions, like including your environmental impact in your cost benefit risk analysis, or your business strategy. So I think all of that is already happening, and it's going to continue to happen. I'm actually very positive. I think that people are getting with the program, they're understanding it, they're moving in the right direction. And they're going to, in order to do that, they're going to have to invest in, something different in the way that they're managing their data. And I think they're waking up to that. Like I said, most of the medium companies are already there. The bigger ones are still trying to DIY, but eventually they'll get there. And the little guys will get there too. I mean, data operations is going to have to change. They can't manage the data the way they have been in the past in these separate little silos. They're going to have to be able to figure out how to merge it, contextualize it, and automate the generation of this data model that enables AI and machine learning and automation. And they'll get there. They'll get there because if they don't get there, they won't survive.
And all of that paints a picture of efficiency, whether or not you're pulling oil and gas out of the ground, or you're running windmills or solar farms. All of it paints a picture of increased reporting of your goal towards net zero. And all of it lets you drive immediate optimizations that help you push further towards net zero. It sounds like everybody, even the American companies, are trying to go net zero. Is that correct?
Yeah, I mean, Exxon has made net zero goals, and Chevron, everybody has, all major companies have.
Okay.
They've all said now, whether it's net zero to 2030, at 2030 or 2050, they all have those goals stated. It's not just about efficiency, though. They also need to think about, the supply chain issue and, coming up with different circular solutions. and either carbon sequestration or carbon capture and some sort of productization of that. It's multiple things are going to have to happen. And I think American companies eventually are going to need to diversify into renewables and other things too, which they're lagging, but they will get there.
I mean, it seems like just simply by the fact that them stating they want to hit net zero, and you couple that with the decrease in cost of wind and solar and renewables and all the innovation happening there, not to mention all the automobile fleets and are moving to electric, it just feels like there's no choice. I don't see how you don't go there.
Absolutely. And you asked the question, so how does this all relate to AI? Well, we're not going to have a single energy source solution like we've had up till now. Everything's been hydrocarbon. It's very simple to manage. Now we're going to have multiple sources, and those sources are not steady. They're intermittent. Solar and wind and things like that are, at the mercy of the elements to some degree. And so you're going to need to do grid optimization in order to, and use storage in order to be able to stabilize those grids. So that's sort of a whole new flowering field around AI and managing multiple sources of data, multiple sources of energy coming into a grid. And then how do you keep that grid really stable?
Yeah, there's also like a lot of distributed pieces there too, right? So now you've got the whole automobile fleet sitting on electric. You've got solar panels and wind turbines going all the way down to homes and neighborhoods. And, you can imagine a world where, you've got extra charge in your Tesla or your Rivian, you park in a garage. The garage is competing based on the fact that it's got solar panels up above, so you can get, carbon-free electricity to juice your car while you're in the office or going wherever. I mean, it feels like in that more
there's some really cool projects and studies that people are doing, like California. In Southern California, they did a study where I think it was PG&E took a bunch of, you mentioned Tesla earlier, there's enough consumers that have Tesla home batteries in Southern California that they were able to do a test to say, okay, what happens if we give these consumers, some break on their per kilowatt hour charge if they allow us to use their storage, their distributed battery storage, 25% of it, if we need it in order to stabilize our grid. And that was a very successful pilot, and it's been done in several other places.
That's interesting. I had not heard about that. That's really
there's another company that's looking at doing that with cars, like hybrid cars that are plugged into a network.
Yeah, let us store the power in your car. We'll pull it out later. Interesting. Yeah, I mean, that stuff becomes feasible between the compute capabilities, the intelligence we can deploy at the algorithmic level, and just we could manage a much more complex energy system that could be more robust even. Well, thanks so much. I feel like we've touched on a lot of topics that are a lot of fun. Is there anything that we didn't talk about that you would like to talk about?
No, this was a great conversation. I really enjoyed it.
That's all for this episode of your AI Injection. As always, thank you so much for tuning in. If you've enjoyed this episode and want to know more about AI in the environment, you can check out a recent article of ours by Googling Xionics Environment or by going to xionics.com/articles. Also, please feel free to tell your friends about us, give us a review, and check out our past episodes at podcast.xionics.com. That's podcast.xionics.com.
That's all for this episode. I'm Deep Dillon, your host, saying check back soon for your next AI injection. In the meantime, if you need help injecting AI into your business, reach out to us at xionics.com. That's XYONIX.com. Whether it's text, audio, video, or other business data, we help all kinds of organizations like yours automatically find and operationalize transformative insights.